Hi students. All right, so today in class we're going to do some reviewing. We'll probably have time to even maybe play some Quizlet. However, it's kind of early to play it because there's some terms in there that we haven't done yet. But we could introduce them that way. So we might do some Quizlet. I do want to make sure you have plenty of time to get your notes done for the rest of this chapter 8, lesson 1. So the homework is going to be to finish those notes. You already should have pages 263 to 265 done. So I need 266 to 269 done. So if you don't have any of those done, you need to get them all done. Okay, the whole chapter 8, lesson 1, you need notes over it. And you should have notes over the table on page 265. Which today's bell ringer is what are the 3 biological functions that water is necessary to do. And that's to transport nutrients and waste. That's 1. And then for photosynthesis, that's 2. And then to regulate body temperature. And there's 3. Okay? So those are the 3. So make sure you have those 3. Those were from that data table, and those were the 3 different bullets. It's that easy. All right, so next I want to introduce the idea of endothermic and exothermic. Endothermic, endo, the prefix coming in, moving inward. Thermic, thermal energy, heat, right? So endothermic is energy coming in, taking energy in. Exothermic, guess what that means, right? Energy out, exiting. Exothermic, energy out, heat out, leaving, exiting. Exothermic, right? So what we're going to do is I've attached to the Google Classroom, I've attached this document, so I want you to read through it, okay? And then, do you see the key on the bottom? This key on the bottom, the blue arrows would be where energy is being released. Released is going to be exo. Released is going to be exo. So things are going to get colder because energy just left them. So the actual item gets colder because energy left them. And then endo, taking energy in. You're taking energy in. So those are going to be your red arrows. Okay? So the way this works is we all know, let's do one we know, evaporation. Evaporation is where the surface of a liquid gets energy in until it has enough energy to break off and be water vapor. Evaporation. That's why that arrow is red. It took energy in. It absorbed energy. It took it in order to do the evaporation. So it's going to be endothermic. So I want you to make those connections to each of these processes of the water cycle. Now, if you're not familiar with sublimation, that's like if you see dry ice at a Halloween party and they put a chunk of a solid dry ice and then boom, the gases come off. It skips the middleman, which is liquid. It goes straight from a solid to a gas. That's sublimation. To reverse that, to go straight from a gas, do not go through condensation, go straight to a solid, that's going to be deposition. So those might be new words to you from the water cycle. So that's what those mean, okay? So those are on that paper, and there's picture diagrams too to help you. So what I would like for you to do, instead of what they say analyze under each photo, write an example of where you might find water in this state of matter. We're not doing that part of this. What I want you to write is sublimation takes energy in, converting solid to gas, and then deposition is energy out, because it's going from a gas to a solid, so it has less energy. Okay, so what I usually try to help the kids understand about energy and the states of matter. All matter, there is no absolute zero. All matter has some movement. Even the desk, all the particles in your desk and stuff are moving, just not very much because it's a solid. So here's a solid, here's the movement of the solid. They're not getting very far from each other. These are two atoms, if you will, and they're not getting very far from each other. They're just boom, boom, boom. They're just kind of bumping up against each other. Add a little energy, and they're able to move a little bit away from each other. This creates a liquid. If you get enough and you meet the melting point, it creates a liquid, and they're able to flow around each other. That's why you can pour liquids. Okay? You add a little more energy, and you end up with a gas. Gases going everywhere. They're moving, they're broken away from each other. They're no longer together. All right? Solid, liquid, gas. That's how the energy works with solid, liquid, gas. Water is unique in that you can find all three of those forms of water in the water cycle. On Earth, you can find it in all three states, solid, liquid, gas. So that's what you're going to be adding to this in class. So if you're not here, you write down below who took energy in and what state of matter they went from and to. Okay? So that's how we're going to use that. Then, and those will be for your notes, because you're going to have to do that. Then tomorrow in class, you're going to draw a water cycle, and along the way, you're going to have to tell me who's endothermic and who's exothermic. Okay, so we're going to practice that again. And then the last thing I wanted to do is make sure you remember that hydrosphere. Hydrosphere is all the liquid water on Earth and in the atmosphere, groundwater included. Okay, so your wells, part of the hydrosphere. Lakes, rivers, streams, ponds, hydrosphere. The puddle in your front yard, hydrosphere. The rain falling from the sky in the atmosphere, hydrosphere. Clouds, hydrosphere. They're all part of the hydrosphere. Hydro meaning water. The Earth is actually broken into several spheres, and one of our other texts did a really nice job of presenting that information, but it's not really standards, so I don't spend a lot of time on it. But there's like the cryosphere, that's the frozen, geosphere, that's the ground. So atmosphere is mostly the gases that we breathe. All right. And then the other thing I want to review is transpiration. Remember that plants transpire water vapor. They give off water vapor. Okay. So transpiration is how the plants contribute water vapor to the atmosphere. All right. Oh, biosphere is another one. Living organisms on the planet, or in the atmosphere too. They're all part of the biosphere. All living things. If it's alive, it's biosphere. If it's water in the liquid state, it's hydrosphere.